equation tonight, and let's just make sure we all remember what the floor symbol means, or the greatest integer function means. So let's just try maybe, let's say 7.6. Okay, the floor just chops off the decimal. That's not very precise actually, but we'll make it a little more precise. The floor of 7.6 is just 7. It's the greatest integer that's less than 7.6. Now, this is because another way of seeing this is 7 is less than or equal to 7.6 strictly less than 8. All right, so any number in this interval between 7 inclusive and 8 exclusive would have a floor of 7. Okay, now let's move on down here. We're dealing with the cubed root of x. The floor equals the floor of the fourth root of x. Now, we develop a couple of lemmas here that really work out very nicely. You can just see that cubing and raising to the third power are inverse functions. The fourth root and raising to the fourth power are inverse functions. Both functions are increasing. And so really these two lemmas follow pretty much from this type of idea right here. Now let's just take a look at a concrete example here. If you took the fourth root of 3 to the fourth, you get 3, right? Okay, and then of course the fourth root of 92, we'll just write it as the fourth root of 92. Less than 4, right? In other words, you just took the fourth root all the way through the inequality. All right, and so it's very clear that 3 has to be the floor of the fourth root of 92. And again, the reasoning is it just goes directly back to this simple example. Okay. Now, so this lemma, both pairs of lemmas come in handy here. I just gave you an example for the fourth root. But this very first part here is fairly clear. If you take the cube root of a number between 0 and 1, you're still going to get a number between 0 and 1, hence the floor is 0, and the same for the fourth root, okay? So we know right off that this is going to be part of the solution set, okay? Now just applying this lemma up here, this lemma all the way down, again, you can see exactly what's going on right here. This would be 2 cubed, right? Okay, which is this part of it right here, right? Okay, this would be 2 to the fourth right here, okay? And so we can see that these two guys intersect exactly between 1 and 8. So let's write that down. 1 is less than or equal to x less than 8. In other words, that interval is contained in the larger interval, okay? Okay, so we can underline that as part of the solution set. Again, folks, this is the larger interval, the floor of x to the 1/4 is equal to 1 exactly between 1 and 16, since the fourth root of 16 is 2. Okay, so we're good on that. Now let's keep going. And it's just similar stuff here, folks. This would be 3 cubed right here, okay? And I'm not going to fill in all of them. This would be what? 2 to the fourth power right here, right? And again, all we're doing is just looking at these lemmas and filling in. I mean, it's just very, very straightforward. Now notice that 8, all the x's between 8 and 27 is contained in this interval right here, right? So again, since this entire interval is contained in this interval, then we're going to get all the x's less than or equal to x strictly less than 27. Okay. And again, similar reasoning gets these intervals right here. And so you can see there's no overlap here. Notice, folks, that there's no intersection going on here. It's kind of close, but you got 81 here, then you have less than or equal to 81. So this would be just the null set, the vacuous set, the empty set. Okay? And so these three underlying intervals union together are the solution intervals. Oops, I made a mistake right here. Sorry, folks. 16, all the values from, 16 would be the lower bound right here, right? Because numbers like 9, 10, 11, and 12 wouldn't be contained in this set, so I made a mistake right here. That should be 16. After I looked at the answer, of course. But y'all see that, right? It's everything that is greater than 16. Well, there's a lot of numbers all the way from 8 to 16 that wouldn't satisfy this, right? It's all the numbers greater than 16, but it has to be less than 27, which would chop off a lot of the numbers to the right over here, right? So that's my mistake. This should be 16 right here. And so notice that these two intervals contain each other, so to speak. They're the same interval because it's strictly less than 1 here. Then you have x is greater than or equal to 1 right here. So this would be 0 closed, if you like this notation. This is the closed interval 0 all the way up to 8 right here. And we'll do open, strictly less than 8. Okay, so again, that's just because of this situation right here. You're strictly less than 1 here, but 1 is included in this interval. So we can write 0, 8. And of course, right here, we can put union 16 to 27. All right, y'all. That's it for tonight.